Welcome to The Explainer. Today, we're going to pull back the curtain on something you use every single day, probably without even realizing it. I'm talking about the invisible architecture that runs our entire digital world. They're called data structures. And yeah, you use them every single time you hit undo or that back button on your browser.
So let's just dive right in with a big question. Think about it. Every single photo you take, every text you send, every file you save, it's all just a massive pile of digital information. How in the world does a computer keep all of that from turning into just total chaos? Well, the answer, and thankfully there is one, isn't magic. To stop all that chaos, computers use these incredibly powerful but totally invisible organizational systems. You can kind of think of them like the ultimate digital librarians, working tirelessly behind the scenes to keep every single piece of data neat, tidy, and exactly where it should be.
And these systems, they have a name: data structures. And they are, quite literally, the building blocks of all modern software. So what is a data structure, really? At its heart, it's just a specific way of storing and organizing data. The whole point, the entire goal, is to arrange information so a computer can get to it, search through it, and update it as fast and efficiently as humanly, or I guess machinely, possible. And this is where it gets really interesting. These aren't just some obscure concepts for programmers. No way. They are the absolute backbone of everything from machine learning algorithms to the massive databases that hold all our info, and even the operating system running on your phone or computer right now. Okay. So even though there are lots of different data structures, they all fall into two main families. And the difference between them? It's actually super easy to get your head around. All right, on one side, you've got linear structures. This is where data elements are just lined up in a sequence, one after the other. A simple to-do list is a perfect example. And on the other side, we have nonlinear structures. Here, the data is set up more like a hierarchy, with items branching out and linking to multiple others. Think of a family tree or a mind map. So let's look at a few common examples. For linear, you're talking about things like arrays, stacks, and queues. For nonlinear, you'll see things like trees and graphs. Now, for this explainer, we're going to zoom in on two of the most important and, honestly, most useful linear structures out there: stacks and queues. Let's kick things off with our first example, the stack. It's a really powerful idea in computer science, but you can understand it with a super simple everyday analogy. And our source material here gives us the absolute perfect mental image for this. Just picture a stack of plates, right? When you wash a plate, you put it on top of the stack. When you need a plate for dinner, you take one from the top. The last plate you put on is always the first one you take off. This exact behavior has a name. It's called the LIFO principle. That's LIFO for last in, first out. The newest thing you add is always the very first one to leave. And this isn't just a helpful way to think about it. It is the strict, unbreakable rule that defines how a stack works. This simple rule means there are really only two main things you can do with a stack. When you add a new item to the top, that's called a push. And when you remove that top item, that's called a pop. Push on, pop off. That's pretty much the whole game. Okay, so where does the simple LIFO idea actually show up? Well, you use it constantly. Think about the back button in your web browser. Every new page you go to gets pushed onto a stack. When you hit back, the last page you visited gets popped right off, taking you to the one before it. And what about the undo function in your text editor or design software? You guessed it, that's a stack too. All right, let's switch gears and look at our second linear structure, the queue. So if a stack is like a pile of plates, a queue works on a principle that every single one of us knows from experience: waiting in line. And this is called the FIFO principle, first in, first out, FIFO. Just like our source material says, picture a line of people waiting for coffee. The first person who got on that line is the first person who gets to order. The data works the exact same way. The first item that gets added to the queue is the first one that gets removed. And the operations? They're just as intuitive. You add a new item to the back of the line, or the rear of the queue. This is called an insert, or sometimes NQ. And when someone at the front gets their coffee, you remove them from the line. That's a delete or deque. So let's just put this all together for a second. A stack is LIFO, last in, first out, like that stack of plates. A queue is FIFO, first in, first out, like a line of people. This one fundamental difference is what makes them perfect for totally different kinds of jobs. But what happens when a simple, straight line just isn't cutting it? When it's not efficient enough? Well,
As you might expect, computer scientists have come up with some pretty clever ways to improve on the basic queue. So here's the problem with a really simple queue, especially if it's in a fixed block of memory. It can be super wasteful. As items get served and leave from the front, you're left with these empty, unusable slots. You can't just stick a new person there. New people have to go all the way to the back.
And the solution to this is pretty brilliant, actually. It's called a circular queue. What it does is it connects the end of the line right back to the beginning. So as soon as a spot opens up at the front, the back of the line can just wrap around and reuse that space. It's like one of those winding lines at an amusement park that snakes back on itself to use every inch of space. And then, for the ultimate in flexibility, you have what's called a double-ended queue, or a DQ for short. Now, a DQ basically says, you know what? Forget the rules. It lets you add or remove items from both the front and the back. It's not strictly FIFO anymore. It's a kind of hybrid structure that gives you the maximum amount of control. So, what does all this mean? It means there's no single best data structure. Not at all. The real skill, the real power, comes from understanding your options: stack, queue, circular queue, DQ, and then choosing the perfect tool for the specific job you're trying to do. And believe me, that choice has very real consequences. If you use the wrong structure for a task, you can end up with software that's slow, buggy, and just feels awful to use. But when you pick the right one, the one whose rules perfectly match the problem you're solving, that's the secret to creating apps that feel fast, responsive, and totally seamless. So everything from the way you undo a typo to how a massive web server handles thousands of requests, it's all built on these simple, elegant systems. They are the true invisible architecture of our digital lives, which kind of leaves us with one last big question to think about. If today's world is built on stacks and queues, what incredible, invisible structures are being designed right now to organize the data of tomorrow?